Today's lesson is on finding the area of a regular polygon. We're going to start with a review of how to find the area of a triangle. Once we do that, we'll talk about what is a regular polygon, what makes a polygon regular, and we'll notice that regular polygons are all around us in the real world. Then what we'll do is we'll break down a regular polygon into a bunch of congruent triangles. And since we know the area of a triangle and we can break a polygon down into triangles, we'll realize that the area of a polygon is just simply equal to the area of all of the triangles that make it up. Using that fact, we will then come up with a formula for a regular polygon, and then using that formula, we'll do some example problems. Okay, so we're going to start with the review of an area of a triangle. The formula for the area of a triangle is 1/2 base times height. So if there's a triangle, there's my base, that's a right angle, so that's my height, because the height is always perpendicular to the base. Here's another triangle, there's my base, and so my height is right there because it is perpendicular to the base. If we forget this formula, we can always calculate it if we remember that any parallelogram can be broken down into two triangles, and the area of a parallelogram is just base times height. So right there I have a parallelogram that's actually a rectangle, which is a kind of parallelogram, and the formula for the whole thing is base times height. So if I divide it into two equal triangles like that, I now have a blue triangle and a red triangle, and if together they add up to base times height, then each one together, or each one alone, must be 1/2 of that. So 1/2 the base times height, thereby proving our formula of the area of a triangle is 1/2 base times height. So a regular polygon, what is a regular polygon? They're polygons that have each side is congruent, so on that example on the right, each of these sides is the same length, and each angle is congruent. So each of these angles here is the same measure. And there are some examples of regular polygons. Equilateral triangle and square you should be very familiar with, of course, and then the other ones just have regular and whatever kind of polygon they are, so regular, pentagon, hexagon, and so forth. And when you look around, you'll notice that regular polygons are everywhere, and not just squares and equilateral triangles. If you are a fan of soccer, soccer balls are made up of regular polygons. A stop sign is just a regular octagon. That building there is a famous building. It's where the Department of Defense is. It's called the Pentagon, and it is shaped like a regular pentagon. And then finally, if you like honey or bees, they make regular hexagons as their honeycomb. And there are lots of other examples as well. And if I take any regular polygon, I can break it down into congruent triangles. So if a polygon has n sides, it can be broken down into n congruent triangles. Let's start with a hexagon. So it has 6 sides, 1, 2, 3, 4, 5, 6, and I can break that down into 6 congruent triangles. 1, 2, 3, 4, 5, and 6. So those 6 triangles together make up a regular hexagon. Let's try another one. This is an octagon. It has 8 sides, 1, 2, 3, 4, 5, 6, 7, 8, and can be broken down into 8 triangles. 1, 2, 3, 4, 5, 6, 7, and 8. So indeed, a regular polygon can be broken down into congruent triangles, triangles that are the same. To find the area of a regular polygon, you find the area of the triangles. So again, here's a problem. Take this hexagon has 6 sides. Therefore, it has 6 triangles. There they are, the ones we just drew on the previous slide. And I'm going to tell you it has a side of 6 centimeters, and since it's regular, all the sides are 2 centimeters. So there it is, 2 centimeters. And each triangle has a height of √3. So there is the height of √3 centimeters. And we call this height the apothem. The apothem is the distance from the center of a polygon to the midpoint of a side. So that height of a triangle is the apothem, because again the apothem goes from the center of the polygon to the center of the midpoint of one of the sides, and that's called the apothem. And so each triangle has an area of 1/2 base times height. So let's plug that in. There's my base. There's my height. So it's 1/2 of 2 times root 3. Multiply that out and I get root 3. So each of those 6 triangles there has an area of root 3 centimeters. And since I have 6 triangles in the hexagon, then if I multiply the number of triangles I have, 6, times the area of each one, root 3, I end up with the area of the polygon is 6 root 3. Now let's use that fact to come up with a formula. There is a regular polygon, and the area of a triangle is 1/2 the base times the height of the triangle. Okay, and then times the number of triangles we have. So in this case we have 8 triangles. We're going to find out the area of one of those triangles and then multiply by the number of triangles, in this case 8. Okay. Now note that the base of each triangle is the side of a polygon. So in our formula, let's change the word base right there into simply the side of a polygon. So in our formula, let's change that. So now instead of having 1/2 base times height times the number of triangles, we're going to have 1/2 times the side times the height times the number of triangles. Now the height of each triangle is the apothem. So I'm just going to switch that out. Instead of height, I'm just going to use the word apothem. So we'll plug that into our formula. And also note that the number of triangles equals the number of sides of the polygon. So instead of number of triangles, I'm just going to call it the number of sides. So now we have 1/2 of each side times the apothem times the number of sides. Finally, let's notice that the perimeter of the polygon, how far it is all the way around that polygon, is equal to the number of polygons, is equal to the side of the polygon times however many sides it has. So the number of polygons, the number of sides times how big each side is, so both those things in blue, and both those things are, as we said, are equal to the perimeter. So let's get rid of those and just put in the word perimeter instead. So the formula for the area of a regular polygon is simply 1/2 the perimeter of the polygon times its apothem, which we can abbreviate as 1/2 PA. Alright, so let's do some example problems. So we're asked to find the area of a regular polygon below, and I know that each side is 10, and the apothem is 5 root 3, and if I count them I see I have 6 sides. To make it easier for you, I've provided you with a graphic organizer. A graphic organizer is kind of like a crutch. When your leg is hurt, you can use a crutch until your leg gets better, and then you get rid of the crutch. So we'll start by using this graphic organizer, and hopefully after using it several times, you won't need it anymore. You'll figure it out and stop using your crutch, but there's no problem using a crutch when we first start. So here is my graphic organizer. It tells me all the information I need. So the first thing I have to plug into it is how many sides I have. And if I count these out, I see I have 6 sides. The length of each side is 10. So as our graphic organizer says, I'm going to take those and multiply them together. 6 times 10 is 60. That's my perimeter. Now I have to plug in my apothem. In this case, it's 5 root 3. Multiply those together, and 5 times 60 is 300. So I have 300 root 3. And then finally, I have to take 1/2 that, because again our formula is 1/2 PA, and I've just taken PA. So 1/2 PA, half of 300 is 150. So the answer, the area of this regular polygon, is exactly 150 root 3. Here's a second example problem. It's asking us to find the area of the regular polygon below, and rather than have the polygon, it just gives us the information. Here is our graphic organizer. I know it's a triangle, and a triangle has 3 sides. The length of each of those sides, as it says, is 10 root 3. If I multiply that together, I get that the perimeter of this triangle is 30 root 3. My apothem, as the problem tells me, is 5. So I multiply my apothem times my perimeter, I get 150 root 3. But to find the area of the polygon, I have to take 1/2 of that, because our formula is 1/2 of PA. So 1/2 of 150 root 3 is 75 root 3.